My name is Fernanda Margarido. I am a professor at IST Lisbon, Portugal. I teach recycling of end-of-life products, and I do research also in the same area. In my free times, I go to cinema, I read books, and I do arts and crafts, basically ceramics. Welcome! The previous video, Level 1, discussed the input, output, and mass flow analysis methods for improving the environmental performance of products and cleaner production. Now, we turn to Level 2, where we talk about methods for the sustainable management of products and improved environmental performance. Producers must improve the environmental performance of their products, identifying the origin of environmental impacts, analyzing each stage of the production system, including also the end-of-life treatment, which affects the environment in different ways. These methods can also influence the performance of upstream and downstream processes. Materials can be changed, or processes performed by suppliers can be improved. After that, the environmental impact of products during its life cycle must be reported for comparing information with similar products. The main concepts exposed in this video are related to life cycle assessment, which can lead to products that are more efficient, help identify bottlenecks, and address different environmental issues. So, let's have a look at life cycle assessment, or LCA. The life cycle of a product is constituted by consecutive and interlinked stages of a product or service system, from the extraction of raw materials, the processing and manufacturing of the product, its transportation or distribution, the use by the consumer, and disposal or recovery of the product after its useful life. LCA is a technique compiling an inventory of relevant inputs and outputs of a product system, evaluating the potential environmental impacts associated with those inputs and outputs, and interpreting the results of the inventory and impact phases in relation to the objectives of the study. LCA is a standardized procedure according to the ISO 14040 and other related standards that analyze the impacts throughout the entire life cycle of a product or system. LCA is a product-oriented method for sustainability analysis. It adds objectivity to the impact assessment of a product system and can be useful for helping companies to understand the environmental performance of their products and services at micro, meso, and macro levels. For example, environmental performance indicators, development of product category rules, or design for recycling. More recently, it includes additional economic and social considerations of sustainability of any given product or service. LCA is an evolving methodology. It is scope-dependent, constrained by data availability, and can be time-consuming. The main phases of LCA are goal and scope, inventory, LCA, impact assessment, interpretation, and improvement. For each phase, I'll outline the steps to be considered. Goal and scope definition is the first phase wherein the reasons for the study, the intended audience, the functional unit, etc. are defined. The fundamental concept always associated is the functional unit of the product or service. The functional unit describes the primary function or functions fulfilled by a product or system, and indicates how much of this function is to be considered in the intended LCA study. On this slide is described the example of the functional unit for lamps, which function in lighting a room can be the number of hours for a given feature, for example, the lumen light. In the second phase, the inventory analysis, primary and secondary data describing the system are collected and converted to a standard format to provide a description of the physical characteristics of the system, which boundaries were previously defined. The inputs and outputs of all life cycle processes have to be determined in terms of material and energy, and the data are processed. The inventory for elementary flows of the previous case study of lamps is shown here. On third phase, which is impact assessment, the physical flows are identified, that is, classification, being assigned to impact categories. For example, methane or carbon dioxide can be assigned to the impact category climate change. Once they are defined and the inventory results are assigned to the impact categories, it is necessary to define characterization factors to quantify into potential environmental impacts, that is, characterization. The impact assessment methodologies can be problem or damage-oriented in their approach. In the problem-oriented approach, the midpoints, flows are classified into environmental themes to which they contribute. These methods aim at simplifying the complexity of hundreds of flows into few environmental areas of interest. Damage-oriented methods, the endpoints, also start by classifying a system's flows into various environmental themes, but then model each environmental theme's damage to human health, ecosystem health, or damage to resources. The degree of uncertainty increases from mid to endpoints. EDIP or CML 2000 are an example of problem-oriented methods. Eco-indicator 99 shows an example of a damage-oriented method. Impact 2002 Plus and Recipe are methods used for combining or harmonizing midpoints and endpoints. The characterization factors for the example of lamps are shown here. These factors should reflect the relative contribution of an inventory result of the impact category indicator. The results are normalized, making use of reference values and aggregated by different impacts to reduce the number of impact categories in the final result, that is, weighting. For example, on a time scale of 100 years, the contribution of 1 kilogram methane to global warming is 25 times as high as the emission of 1 kilogram of carbon dioxide. This means that if the characterization factor of carbon dioxide is 1, the characterization factor of methane is 25. Normalization is a procedure needed to show to what extent an impact category has a significant contribution to the overall environmental problem. Normalization for the case study of the lamp is described here. On the interpretation first phase, results are evaluated and interpreted in the context of their significance, uncertainty, and so on. After performing these 4 phases, the system should be modified in some way to reduce or improve the observed environmental impacts of products and services, minimizing production costs, environmental and human health, damage, and understanding trade-offs between multiple impact categories and product phases. This concludes the first part of Level 2. In the next video, we learn about some additional tools for improvement in environmental performance of products. Thank you for your attention.